Harvey. I am a calculus teacher here at Hibbing High School, and I've also been a swimming coach for about 24 years here. So we have this really nice pool down in Hibbing High School. It was built in '91. It's a nice 8-lane, 20-yard wide, 25 yards long competition pool. And we've also had kind of a running argument of how many gallons of water were in there. So last week in class, we were going over the trapezoidal rule and Simpson's rule, and I thought that why don't I use this to find out how many gallons of water were in. So what I did is I went along the side of the pool and I took a long tape measure, 100-foot tape measure, and I went across here, and every 5 feet I dropped a weighted tape measure down from here to the bottom of the pool and recorded all the weights. It starts here at 10 feet deep, says right on the wall. It goes down to 13 feet deep right here, 10 feet away from the wall, and eventually ends up at 3.5 feet deep there. So what I'm doing is I'm using the trapezoidal rule to get me a cross-sectional area of what that sidewall is. And then when I get done with that, since this is a prism all the way back up like that way, I just multiply it by 60 feet. So I will calculate how many cubic feet of water in the pool, convert that to cubic yards, convert that to gallons, and have a go. So I was wondering how to do all this stuff, and when I did these measurements here, it worked out very nicely because they either came out to a nice round inch value or very close. So there's a little bit of fudge room in here, but not a whole lot. They pretty much came out very nice. You can see how the drop went from there, 1.5 feet to there, then up, and it gets a little more gradual right there. And then I got here, great, it came out to 9 inches, so I could make it 3/4 of a foot. This one came out to 11 inches, so I used 11/12 as a calculation here. And this came out to 9 inches again, so I could use 3/4. And it was really nice. This one came out to 8 inches, so I was able to use 2/3. And it really worked out very nicely. So those are all my measurements that go here. There's my 10 feet, my 11.5 feet, my 13 feet, 12.5, 11.5, 10.5, 9.5, 7 3/4, 4 11/12, and then it has a much gradual rise when you go from there to the final end. So here's how my calculation works. Trapezoidal rule works by taking a bunch of trapezoids. It basically takes this right here and it treats it as a trapezoid. And of course the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Well, the height would be this right here, and it's constant at 5 feet every single time. And then this is my base 1, and that's my base 2. And then when I go to this one, I do the same thing over here, except for now it's 1/2 of my height, base 2 plus base 3. So this one gets used double every time. Every one of these inside ones gets used double, and this one on the outside here, and this one on the outside here only gets used once. So if I ran that all out, I could do this. I could factor out the B minus A. That is the total span that I'm going from 0 to 75. So that is 75 feet up there. Over 2 times n, I took 15 partitions. I have 16 heights, but I have 15 partitions. Times 1 times my first height. My first height was 10 feet. Plus 2 times my second height. And I have all these on a sheet of paper to make this go a little easier for me. 11.5 plus 2 times 13 plus 2 times 12.5 plus 2 times 10.5 plus 2 times 9.5 plus 2 times 7.75, and I'm running out of room, I'm just going to come down to here, plus 2 times, I'm at 7.75, I'm losing my count here, 7.75 plus 2 times 4.916, which is that 11/12 fraction. And when I did this, I went like that and I typed her way out a ways so I could be as most accurate. Plus 2 times 4.75 plus 2 times 4.5 plus 2 times 4.3 repeating. Again, when I typed into the calculator, I went out and filled her up. Plus 2 times 4.083, that signifies that 1/12, that 1 inch, plus 2 times 3.916, plus 2 times 3.6, and then finally my last one, which is 1 times 3.5. So when I did this, typed all this into the calculator, I ended up getting 75 divided by 30 times, this ended up being 196. Came out just nice and even. Again, I filled up with digits, and it came out just the way you want it to. So it came out at 196. If you do this right here, this calculation, you get 490 feet squared. That's this area right here. 490 square feet. So now I want to find the volume of this swimming pool. So I took this and I multiplied it by 60 feet, because it's 20 yards across. So I multiply it by 60 and I get a total cubic feet of 29,400 feet cubed. Now, it does not tell me how many gallons of water there is in there. However, there's a conversion that says every 1 cubic feet of water is equal to 7.48052 US gallons. So, for every one of these guys, I multiply by 7.482. So I took my 29,400 and I multiplied it by 7.48052, and I got 219,927 gallons of water in the swimming pool that I work in every single day, thus answering my question. I would have liked to have done this a little better with maybe a laser to get these heights, but I was also able to get this by staying dry. I didn't have to get my suit on and get wet and jump in the pool. I'm awaiting I just came up with this idea last Friday after we did trapezoidal and Simpson's rule. I went to the architect, he's a friend of mine that designed this pool, and I asked him for the specs in it. He's digging it up, and he's going to tell me what they think the actual gallons of water is in there. But I think it's somewhere right around here. I also did it a different way. These are pretty nice. This is 10 feet to here. So I actually went through and I did this. And I looked at this as a trapezoid right here. Up to here, pretty level to there, I went and looked at that as a trapezoid. And I very crudely did this, where I just pasted off, because I already put the measuring equipment away. So I just paste this off knowing that's 13 feet. Paste this off knowing that was, I believe, 5.5. And then this. And I literally went through and used the area of a trapezoid, found the area of this, the area of this, and the area of this, added it together, multiplied it out, and I ended up getting, I want to say I got 225 gallons, 225,000 gallons when I did that. So even by just crudely measuring it this way here, I was really close, right in the ballpark. And if I wanted to spend some time and get really accurate measurements, it would be great. I also wanted to use Simpson's rule on there, but Simpson's rule states you need an even number of partitions. And with working with 25 yards, it was going to be easiest to go every yard, or if you go to 75 feet, to go every feet, both of which would be odd numbers. So it wouldn't work all that well. So there's how many gallons of water is in our 8-lane, 25-yard competition swimming and diving pool in Hibbing, Minnesota.